Hello everybody, so today I will talk about the Ticketmaster game. So last Sunday I talked about this design and I talked until the high level design along with the I should say strong consistency, so the rocking of DB. So but obviously it wasn't a good video. I missed something very important, so I'd like to do a kind of follow-up for the design Ticketmaster video part 1 take 2 as the take 2 here. So okay, let me get started. So functional requirement is okay, non-functional requirement was okay, but for core entities I overlooked something important. So I actually mentioned this while I was explaining verbally, but I didn't include the performer. So event has the performer who performs something. So it needs the performer, entity here. Okay, and for API design, this was okay. Get event API was okay. Get event API was okay. Get seed was okay. But for book seed API, obviously we have to know which user is doing this operation. So I think what I can do here is in the header, I include the session token, and the backend system API gateway can identify which user it is. So here from session token, we know which user is operating it. So so that's the thing I missed in the last video. And another thing I'd like to follow up is I didn't include the payment system here. So obviously when user makes the bookings, he needs to make the payment, but I didn't talk about it. So let me add it here. So the thing is, which one is it? So in the book seat, so what happens is let's think of the very naive case. So easy site like Amazon, or in the obviously in the Ticketmaster in the real world, when user selects the seat, he's given like the graceful time period, like 10 minutes, and user can make the pay. User should make the purchase. User should make the payment in the 10 minutes, and then if it's done, the booking is consolidated, finalized. But if the user cannot finish the payment in the 10 minutes, he loses the right to book the seat. So this is the reality and the ideal, specification. But for now, I will start with the simpler case. So, or I should say, user should make the payment first, and then when it's done, the booking record is created in the DB. But if it fails, what happens is that there is a refund for that user. So in the user's bill of the credit card, he can see one payment and then refund. So that being said, let me tell you how I can do it. So I will use some kind of payment system here, which is third party, like Stripe. So Stripe is something we can store the credit card information. So the thing is, if we'd like to store the credit card in a system, we have to comply with the PCI regulation, but it very strict. It has a very strict requirement. So for the startups, they usually use the third-party payment processor. So what happens is user saves the card information and we get the kind of token from the payment system, and then user directory stores the card information in the UI, and then booking system makes the kind of API call to make the payment. It should be obviously authorized capture model based usually. So authorize and capture request, and then the payment is done. And when the payment is done, usually there is a webhook. So, and it's a good idea that we create another service for the webhook API. So here, when the payment is done, this payment system make a webhook to the payment webhook's receiver, and what I can do is we should kind of include the maybe what I can do is I should include the payment ID or payment token, or I should say my payment ID here. In the seed table. Then when payment webhook receiver receives a request from Stripe, he checks it and finds the recode, and if wait a minute, what I was talking. So yeah, now I remember. So payment token ID is given. So what I need to include is a kind of mapping from my payment token ID to the seed ID. So let me quickly stop my video to look up something. Okay, so I quickly searched something. So yeah, instead of looking up the payment transaction ID to seed ID here, what I can use is the metadata in the webhook AP webhook. So this includes metadata like original seed ID, and now this payment webhook receiver confirms which seed ID was reserved. But let me tell you something. So, but the thing is, booking service searches event, and so obviously this is missing something. Yeah, okay, sorry. This is good, I think. In this way. So yeah, in this way, the booking is done. But I have something I'd like to update a little bit. So yeah, what I can do is, and what I should do is separate this seed ID and booking ID, because seed should represent a single entity of the seed in the venue, And I'd like to make another model named booking, because booking can have the kind of maybe ticketed out, or maybe the flag which represent if the user finally came to the concert or not. So that's why I'd like to separate booking. And I can say this booking is a kind of relation table between the seat and user. Okay, and I include booked and version in this table instead of seat table. Okay, so now what I should do is update book table here, booking table here. And what I can do here is I create this booking table in bulk when the concert is, planned. So in this way, just like what I explained for the seat, in the last video I explained that I can do the optimistic concurrency control on the seat table, but I can do the same thing with the booking table because the row already exists. So if the booking comes, if there is a process that would like to make the booking, he just have to look at the booking record and update the booking user ID or something. So this is something I had to do to increase the payment. And as I said, I'd like to give users a 10-minute time for user to make the payment. So I will talk about it. To be honest, I have 3 things I'd like to talk more in this video. Number 1, about the time. 10-minute grace for time for payment. Number 2, I'd like to talk about the cap theorem. I talked about this cap theorem in the last video here, but I kind of hand-waved the detail, so I'd like to explain it again here, just for my practice actually. And also I'd like to talk about the strong consistency. So I talked about isolation level versus pessimistic locking versus optimistic locking. So I talked about it last time, but it was I struggled to explain this, so I'd like to talk about this again here. Okay, so now let me start with the first one. So my English was not good, so I should call it grace time or grace period. Okay, so 10 minutes grace time for payment. So what I can do here is in the booking table, so I should frame it in this way. So even if the payment is not done, that seat should be kind of secured by that user. Otherwise, even if the booking is not finalized, if there are 2 users who'd like to pay for that seat, they do the double payment, and in the end, one of them has to be refunded the money, which is not a good user experience. So I'd like to this booked ad. I'd like to change this to secure that, I should say reserve that. Yeah. Okay, so yeah, I will do it. So how should I say? Let me see. Yeah, secure that. Okay. So now what I can say is, when I do the query, okay, so wait a minute. So I do include this secured add. So now I can say something like this. So this seed is free to be taken if secured add is null or secured add is less than now plus 10 minutes. If this is true, it means that this book ticket is available. This seat is available now. But otherwise, this is not available. Okay, so yeah. Okay, and I actually have to combine this with the version key. So now this query should be updated as query form add seed. I think this is get. So sorry. So last time when I took this video, I was a bit tired, and also this is my first video. After a while, I was a bit, yeah, everything's so good. So for query 1, I get seed version key. Then in query number 2, I try to update seed, and I try to specify version so that I'm looking at the latest version, and with user ID book that version is 4. What I'm doing here. I see. This is update query. And to be honest, I actually forgot to include in my last video. I should have done here where version is 3 and booked at is null. But I forgot it. Or maybe booked at. Yeah, it's null. Yeah, I needed it, but I forgot to do it. So anyway, now I need to include this here. So version is specified to avoid the race condition, and also I specify secure that is null or secure that is now plus 10 minutes. Now plus 10 minutes. Secured out. Secured. Maybe I should say secured until, and I include 10 minutes later. So here I can do something like this with user ID book.version. So these are updated with, but I need secure that. And also I need user ID is null here. Otherwise I could take a seat which is already booked. So I correct? No, maybe I'm not. This is not true. Get here. I should get a variable seed with version column. Then, if this version is not changed, I can say this seed is not secured yet, so I actually don't need this. And instead, here, I need this condition so that I can take a look at the seed which is not secured yet. Okay. So in this way, yeah, I think this is good. So maybe, and maybe I need another something like booked at here. So secured until is for the grace time, and booked at is exactly the time when this is booked at. So the reason why I add this is because if I try to check if this booking is taken by someone by seeing the user ID, I cannot put the user ID until booking is done. But obviously I try to put this user ID when the seat is secured, not at the booking time. I mean before the booking time. So I'd like to include booked at too. Now what I can do is booked at is new. So this means the seat is not finalized yet, and secured until is new. Yeah, this is okay. So I try to confirm this is not booked yet, and also this is not secured yet. So now if I could confirm this, it means that this seat is, possible to be booked. And obviously, when I update the booking, I think I have to, update the booked at too. This is a bit confusing. So version key. So which should be checked? It is quite confusing. So let me, maybe I will take another video after completely understanding this. But the concept is something looks like this. Yeah. So basically, this is a kind of state machine. So if there is a seed, there is 3 status: booked, secured, and not secured. Okay, so now let me talk about this non-functional requirements, term consistency. So yeah, I hand-waved this so much last time, so I'd like to explain this a little more clearly. So firstly, maybe I should start with explaining what is cap. So again, cap is consistency, availability, and partition tolerance. So this is a kind of characteristics to be characteristic in the distributed system. So maybe I should start with partition tolerance. So partition tolerance is if there is a network disconnection, the system keeps working. And for consistency, this is something that if there are 2, let's say, processes which would like to take a look at the same data. No, sorry. So let's say there is a data and there is one process which updated, And there's another process which reads from that data. Consistency is every time the reader can take a look at the data which is updated by the latest write. Or I should say, latest write is always read immediately. So that is consistency. And availability is even if there is a problem in the network connection. Oh, sorry, no. Or I should say, availability is no matter what happens, the system keeps working. Okay, so let's say there is a partition tolerance. And actually, partition tolerance, wait a minute, is something I'd rarely have to think of. Oh wait, why do I always have to think partition is mandatory? Partition tolerance is mandatory. Let me search and come back. Okay, now I see. So when I think of the cap theorem, partition tolerance, I should think of the quite extreme case. So let's say there is a partition tolerance. There isn't partition tolerance guaranteed. In that case, if there is any network breakdown, the system stops working. So it's not something we'd like to, prioritize, obviously. So, am I correct? In which case I can guarantee C and A. Okay, let me stop the video and come back. Okay, I'm back. So what I learned is, so I was so confused. What's the difference between availability and partition tolerance? Because in my understanding before, partition tolerance is even if the partition disability happens, they keep working. It sounds like availability, but actually not. So, okay, so partition tolerance is how the system should handle their network disconnection. So if the system decides that they stop working, it's the kind of decisions the system made. So it means that the system has a partition tolerance. So it doesn't mean the system keeps working. It's the availability. A little bit confusing. So that being said, obviously we need the partition tolerance because even if the network disability occurs, we'd like the system to make the decision in a correct way. And that being said, my question is, should I prioritize consistency or availability? So yeah, and let's think what happens if there is a network disconnection. Let's say, I will think of the read replica of DB because it's a very good example. So there is a writer process which updates the master recode, and there is a kind of asynchronous update from the master recode to the replica recode, but there is a partition tolerance between them. So master recode update is not propagated to the replica recode update. So in that case, if I'd like to guarantee the consistency, we should stop the replica node to return the response because it cannot return the latest status. So in that case, I can say I prioritize the strong consistency and doesn't suppose the availability. But if I allow the eventual consistency, not the strong consistency, it is okay that the reader fetches the not latest record. In that case, the system's replica data should return the bit outdated data to the reader process. In that case, I can say consistency is not guaranteed, but availability is guaranteed. And in the case of this, Ticketmaster, for the seat booking, it's specifically we need a strong consistency, because if there is a user who secures or books the seat, we don't want other users to see the old status, like the seat is not booked yet. Seat is not booked at any moment. So we need the strong consistency. Yeah. However, for others, like the event description, it is okay that we support the eventual consistency, not strong consistency, and instead we guarantee the availability. So if there's a reader who'd like to take a look at the event description, even if it is a bit outdated, that maybe it's not the latest status, not the latest record is returned. Yeah. So this is about the cap theorem. Yeah. So again, my misunderstanding and my confusion is about the partition tolerance. I was thinking that partition tolerance is something like if there is a network disconnection, the system keeps working. But as I said, it's not true. The partition tolerance is if there is a network disconnection, system can decide how to handle it. Yeah. So without losing sanity. Okay, so that's about the P, partition tolerance. Okay, so finally number 3, strong consistency. So I will explain this again with this, description here. So as I said, what I try to, guarantee here is the strong consistency. So if there is a user, there is a process who'd like to take a look at the DB seat record, or I should say booking record, I'd like to, what should I say, make sure that the process always can read the latest write from another process, or maybe by that process. So what I can do is, okay, so and the race condition which makes it impossible is like this situation. Read, write, B's read is intertwined between A's read and write. So that's what I have to avoid. So to avoid this, I can use the PostgreSQL's built-in capabilities. So the option number 1 is isolation level, serializable isolation level. So this happens that this operation works without okay, so basically I use isolation level serializable and also put these read and write operations in one transaction. In that way, 2 transactions occurs in a serialized way, which means that no intertwining. But this doesn't mean that it completely waits first transaction to be done and the second transaction to be occurred. like in the queue. If I think of that in a queue, waiting queue, it is kind of linearizable level. But serializable level is after, looking back, if multiple transactions can be sorted, and let's say the data is updated in that order, everything is, there's no contradictions. In that case, I can say it's serializable rather. Transactions are, handled in serializable way. So yeah, so that's the isolation level. And the second option is pessimistic lock on the row, on the single record. So what I do is start the transaction and select for update statement. So this always reads the data from the master node in the database, even if there is a read replica, and update it. So when I do select for update, it takes the log of that row by selected row, and it means that it doesn't allow other users. Okay, what should I say? Because if there is let me rephrase. Let's say there is another process who would like to do the same thing. Because that another process, there's a process, starts the transaction, they have to take starts the transaction and do select for update. It has to take the log. So every process who'd like to take who'd like to do this query has to take the log of that row. This means that these processes, queries are, waiting in the queue to be handled. So in that way, I can avoid the, race condition. And for optimistic concurrency control, optimistic locks, I use the version key. So when I try to get something, get the record, or maybe I should say, for that record, I add a new column, kind of version key, for the specific row I'd like to control and avoid the race condition. And every time that row, that column, that attribute is updated, that process also updates the version key by 1. So in that way, firstly, the process fetches the record and gets the version key. Then, when it tries to update it, it makes a query like I'd like to update this record with version key 3, which is the original just fetched version key, with version key set with version 4. 3 plus 1 is 4. In that way, what happens? So if there is another process who happen to update the version key to 4 with a new attribute value, the second one, who was late, cannot find it because where clause doesn't filter that version, that row anymore. So in that way, optimistic concurrency control works. Yeah. Okay, so that's the optimistic concurrency control. And so what happens if he cannot find it? So just the query fails. So the client has to try it again. He has to try the latest version key again and then update it again. So this isn't good when there is a lot of race condition predicted. I mean, there's so many processes, processes. It is predicted that so many processes update the same record at the same time. This doesn't work. But in that case, I should use the pessimistic rocking, because instead of them to retry and retry and retry, they should be waiting in the queue until his query is processed. But in this case, I would choose optimistic concurrency control, because they don't have to reply. Once that seat is taken by someone else, the seat is not available, so there's no point retrying and retrying to update the record. So that's why, I mean, in that sense, the query doesn't have to wait in the queue, so I would choose the optimistic concurrency control here in this scenario. Okay, so that's what I wanted to explain today. Yeah. Okay, thank you. So yeah, I know my explanation is not so good, but I will keep posting something. Yeah, I try to record my progress here, and also obviously even also there is a saying in the kind of writing world that if you don't write anything, it cannot be modified. But if you write something, even if it is terrible, it is possible to modify and edit it, and you can improve. So even if this is terrible, I will keep posting this. So thank you so much. Bye.